Raytheon has delivered and installed the first AN SPY-6 V4 radar array at the U.S. Navy's Surface Combat Systems Center at Wallops Island, Virginia, marking a major milestone in the Flight IIA Arleigh Burke-class destroyer modernization program. The company announced the development in a statement issued on August 3rd. Located on Virginia's Atlantic coast, the Wallops Island facility serves as the Navy's land-based test site for integrated combat systems, providing an open ocean environment for evaluating advanced radar and sensor technologies under operationally representative conditions. This is a significant development that deserves objective analysis. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. The AN SPY-6 is the U.S. Navy's next-generation active electronically scanned array, AESA, three-dimensional air and missile defense radar. The SPY-6 family is being fielded across multiple surface combatants and capital ships, including upgraded Flight IIA and Flight IIA Arleigh Burke-class destroyers, Gerald R. Ford-class aircraft carriers, and San Antonio-class amphibious transport docks, creating a common radar architecture across much of the fleet. For the Arleigh Burke-class, two variants are being deployed. SPY-6V1, also known as the Air and Missile Defense Radar, with 4 phased array faces, each containing 37 RMAs. It offers up to 15 decibels more sensitivity than the older SPY-1 radar, meaning it can detect targets half the size at double the distance. This version is built for Flight III destroyers. The AN SPY-6 V4 is a smaller version with 24 RMAs per array. It's designed to retrofit in Flight IIA destroyers, bringing them a major leap in capability without a full rebuild. Fully integrated with the Aegis combat system, it delivers significantly greater detection range, higher sensitivity, improved target discrimination, and enhanced tracking capacity, allowing the combat system to engage more complex and densely populated threat environments. Exact classified performance numbers, precise range, RCS thresholds, etc., are not publicly released, but open-source statements consistently describe order-of-magnitude improvements in sensitivity and track capacity. A defining feature of SPY-6 is its scalable modular architecture. The radar is constructed from standardized radar modular assemblies, RMAs, which can be combined in different configurations to meet the performance requirements of various ship classes. This modular approach simplifies production, reduces lifecycle costs, streamlines maintenance, and facilitates future capability upgrades across the fleet. The SPY-6 system consists of 2 primary radar arrays and a radar suite controller that coordinates overall sensor operations. Its S-band radar provides long-range volume search, precision tracking of ballistic missiles and other airborne targets, and supports key communications functions, forming the backbone of the ship's integrated air and missile defense capability. The X-band radar complements the S-band array by providing high-precision target tracking, horizon search, and terminal target illumination. Working together, the 2 radar systems also support navigation, periscope detection, and missile guidance, enhancing the ship's overall situational awareness and combat effectiveness. The SPY-6 employs gallium nitride, GaN, base transmit/receive modules, a significant advancement over the gallium arsenide technology used in earlier naval radars. GaN semiconductors offer substantially higher power density, improved efficiency, and greater thermal performance. Although the SPY-6 requires approximately twice the electrical power of its predecessor, depending on the variant, it delivers more than 35 times the effective radar power, dramatically increasing detection range, tracking capacity, and performance against low observable and highly maneuverable threats. While the SPY-6 was not originally developed as an electronic attack system, its AESA architecture provides the technical foundation for future electronic warfare capabilities. With appropriate software and system enhancements, the radar could potentially perform functions such as electronic attack, jamming, or other advanced electromagnetic operations alongside its primary sensing mission. The newly installed SPY-6 V4 radar will undergo extensive testing alongside its associated power and Aegis combat system interfaces before being installed aboard USS Pinckney DDG-91, the first Flight IIA Arleigh Burke-class destroyer scheduled to receive the SPY-6 V4 under the Navy's radar backfit program. According to Raytheon, initial testing is expected to begin later this year and continue through mid-2028, validating the radar's performance and system integration ahead of fleet deployment. Barbara Borgonovi, Raytheon's president of naval power, stated, "By leveraging the Wallops test site, we'll be able to integrate SPY-6 V4 with its dedicated power system before it reaches the ship, reducing the amount of testing needed on DDG-91. That means less time in the shipyard, more time dedicated to the mission, and a smoother path for future backfit ships." USS Pinckney could have the installation completed by 2028. The planned approach is intended to reduce technical risk, streamline the transition from land-based testing to shipboard deployment, and ensure a more efficient integration process during the destroyer's modernization. SPY-6 V4 transforms Flight IIA destroyers from capable but aging Aegis platforms into ships with near-flight 3-level radar performance against the densest and most advanced threats, while retaining modularity and commonality across the SPY-6 family. The improvements substantially increase general situational awareness and effectiveness of interceptors such as the SM-6 missile. Importantly, it will trickle down to old vessels too. Over the coming decade, more than 50 U.S. Navy warships are expected to be equipped with variants of the AN SPY-6 radar, making it the service's standard air and missile defense sensor across multiple classes of surface combatants and capital ships. The AN SPY-6 V4 upgrade is particularly significant for the Flight IIA Arleigh Burke-class destroyers, ensuring that the backbone of the Navy's surface fleet remains capable of countering increasingly sophisticated threats, including advanced ballistic missiles, cruise missiles, hypersonic weapons, and low-observable aircraft. Over the years, the weapons in Arleigh Burke-class destroyer have seen many significant upgrades. For example, latest variant of Tomahawk cruise missile, the Block 5, incorporates improved anti-jamming measures, an upgraded mission computer, enhanced communications for two-way satellite updates, integration with modern battle networks, and even has an anti-ship variant. With the key sensor now being upgraded, the ships will essentially get a new life. To support growing demand, RTX has invested approximately $800 million to expand and modernize its radar manufacturing facilities. The investment is intended to increase production capacity and, by 2028, double the annual output of AN SPY-6 radar systems. The expanded production capability will support both newly constructed warships and the modernization of existing vessels, ensuring the timely delivery of next-generation radar systems across the fleet.